Hello everyone. So give me a few minutes. Let me check if we are live. Yeah. Hello everyone. It was a weird contest. Did only three. Uh, yes. To a surprise, Div 2 was like first three question was like 800, 800, and 800. Then it was a 17, 1800 question. Then uh, DP on probabilities kind of question. So I can say around the rating was quite weird. Uh, okay, so we will wait for 4 more minutes, then we will start. Until then, you can just tell me how many questions you were able to solve and what are all the ideas and intuitions like that. You can go ahead by writing in the chat. Four. Wow. Hi. Four in div 3 or div 4? Oh, sorry, div 2. Div 2 or div 2. What was the rating for fifth and sixth in div 2? Oh, fifth was around 2000 something like or more than 2000 I can say like that. Because it was a DPN probabilities kind of thing. It may be 2000 near 2006. I was not able to solve the sixth. It might go 2200 or 2300 something. Hmm. First three were very easy. Like you can just look at the problem and go ahead. Any? Oh, uh, can you guys just guess what was the you know problem tags for the fourth problem in the division two? Anyone can guess? Problem tags. What kind of like problem it was? Any ideas? They asked us like there are only two test cases. One we have gave and you can try the second one. Just like that. I was able to solve only three. No problem. The next problem was quite good. Fourth step. Yes. No problem. You can just look at the editorial now. And please let me know during the whole uh, live that if there is any problem in explanation or is there something that you are not able to understand. You can just mention in the chat. I will look at it and I will definitely um, explain it to you for in more clear way or more easy way. Okay. Maths. It was kind of ad hoc type. I was able to come up with an ad hoc solution. Like my even my output was not matching to the output that he gave. I will tell you the ad hoc part what I had done. It is okay. Okay. Mm, so let's start with the editorial. Okay. So good evening, everyone. Today we are going to start with CodeChef Starters 222, and let's move towards the first problem of today's contest. Okay, so the problem name is layered cake, and in this problem, you are given with Chef is making a layered cake consisting of two layers. Okay, so keep these thing in mind. Like there are some points which you have to note down. Okay, so that there are two layers, you need to make sure that you remember all these things or these observations. Chef has n options for the first layer representing by an array a1 to an, where ai is the represented the size of the ith layer of the first cake. Okay, so ai represents the size of the first layer. Similarly, chef has m options for the second layer represented by a array b1 to bm, where bi represents the size of the second layer. Okay, chef must ensure that the size of the second layer is strictly smaller than the size of the first layer. Okay, no problem, Jia. You can just look at the editorial now. How many possible cakes you can make by combining first layer and the second layer while respecting the constant? Okay, so first of all, the problem is n is 100. You can directly brute force it without thinking, and it will definitely work every single time. But we are not here to brute force. Okay, let's try to do in more optimized way. Okay, so the first problem what is given as like there is a cake. Okay, which is two layers. This is my first layer. This is my second layer. And what you have said that the size of the second layer must be strictly smaller. The size of the second layer must be strictly smaller than the size of first layer. So cake will look like something look like this. Okay, this is my first layer and this is my second layer. So this will be like your cake. Okay. Now for the first layer, I have n options to choose, which were a1, a2 up to an. And for the second layer, I have m options, which were b1, b2 up to bn. Okay. Now you can what you are asked is you need to count how many possible combinations you can make such that when you choose AI and BJ, AI must be strictly greater than BJ. Okay, good. For in the div 3, quite nice. So you need to count how many combination of I and J exist. Okay, first to satisfy this condition. Either you can just do a double loop of for right of I and J and then count how many pairs do exist, and it will work because n and m is 100, so it will go up to 10 is to power 4, which is easy to do. But what I can do is I need to just find right now a point where AI is greater than BJ. I need to find that point. What if I sort the B array? Like if this is a sorted B array, say BM, so there will be some point, let's say BK, where your AI is always greater. Okay, this is the point where AI is greater than BK, and the previous value AI is always greater, and for the next value it is smaller. Okay, AI is smaller or equals to. So this is my critical point here. So I can just directly count how many elements are there. Yes or no? By taking the index of this. Correct. So what I can do, I can sort my B array. Sort the array B. Correct. While after sorting the array B, what I can do, I will iterate over A, and then for each AI, I will find the index. where AI is just less than AI is just greater than BK. So AI is just greater than BK. So I will find this index. Then I can just calculate how many uh, indexes are there by taking current index minus. Uh, you can do a zero if we are finding index through proper binary search, or if you are doing a lower bound, you can take a IT star and then this subtract your IT dot begin B dot begin. Right. This is something if you are doing a lower bound approach. Okay. So this was the whole problem. Like you just need to what you need to do. You can just sort the array for each AI. Check the crucial point where on the left all the elements are smaller than AI, and on the right all the elements are greater than AI. And after that, you just count how many points are there for each AI by just adding it. So this will take around m log m for sorting and iteration n also for log m to find binary search index. Okay, so total time complexity is m log n plus n log m. Okay, so in this time complexity, you can just directly find this answer. Okay, so if we look at the code, what I've done, I have taken n and m as input. I have taken array A and array B as input. Then I have sorted the whole array B. Okay, I have made my answer as 0. Then I have iterated over the n, which means I have iterated over the array A. And then what I have done, I have done a lower bound binary search on the array B to find the crucial point AI. Why lower bound and why not upper bound? Because lower bound gives you strictly less than index, and upper bound gives you strictly less than equals to index, less than equals to. Okay, so you can do lower bound on array B to find that particular index, and total number of values which are between that index and 0. It is just index. You can subtract it by b dot begin and just add it to your answer. Then you can just output your answer. Okay. This was the optimized approach for the problem. You can also do twice a loop, which is quite easy. Okay. Is this clear? We can move towards the second problem. Oh, you can just mention in the comments like, yeah, yes or no. That would be great. Is this clear? Any doubt in this? Any point? Any finish task? If not, I'm moving towards the second problem. Okay. Okay. The second problem. Okay. In this problem, you are given with sorting prefixes, and you are given with an array A, which is a permutation of integers from 1 to n. Okay. Your task is to sort the array using the following operations as many times as you want. Okay. Choose an index IE, then pay AI coins to sort the prefix AI, prefix A 1 to I of the array. Okay. Note that the cost is levied before the sorting operation is performed. Okay. Here A 1 to I represent the prefix A1, A2 up to AN. Okay. What is the minimum total cost of sorting the array? Okay. Now, if you look at this thing, you will get your answer directly. Let's break this question. In this problem, you are given with an array A, A1, A2, A3, A up to AN. and this array is a permutation of numbers 1 to n. Okay, so numbers will be like 1, 2, 3, 4, 5, or up to n, or they can be rearranged in any form. Correct. Now you want to sort this array. Let's take any random example. Okay, say I take an example 5, 4, 1, 2, 3, 6, and 7. Okay, so this is my permutation. I need to sort it. Now to sort a permutation, what I can do, I have an operation which I can perform on any index. Like if I take this index and I can perform my operation, so this total prefix from 0 to that index will be sorted. So if you sort this, it will look like 1, 2, 4, 5. Okay, and then 3, 6, 7 will be copied. Now this will be my new array, and the total cost what I have paid is 2. Okay, so this will be my cost to till now. Now what I can do, I can just take this index and sort the array. So this array will be sorted. It will convert into 1, 2, 3, 4, 5, 6, 7. Alright. So total cost what I paid is cost is equals to 3. So if I add them, the total cost is 5. So I've done this sorting operation and total 5 cost. But can I do it in better, like uh, can I do in less cost? Yes, it is possible. How? Let's take the same example. 5, 4, 1, 2, 3, 6, and 7. Yeah, now I am directly taking this particular index. Okay, so this complete array sub array will be sorted. So it will look like 1, 2, 3, 4, 5, 6, and 7. All it now what is the total cost what I have gave? Total cost I gave, that is 3 to sort the whole array, which means I can do in a better cost with better cost efficiency. So what will be my key idea? My key idea will be, if you look, they are saying the array is a permutation. So whatever A1, A2 up to AN is given, I don't care about this. After sorting, it will definitely will be looking like 1, 2, 3, 4, 5 up to N. Correct. Also, what I what operation I have is I can sort a prefix from 1 to N, 1 to K. Let's say K. Okay. So if I am choosing a index K, so I can sort from 1 to K. So all the prefixes are sorting. Sorting is done on all the prefixes like these, but suffixes are not affected by this sorting. Correct. So what I can say is, if I iterate my loop backward, okay, and then I check if this an and this particular n are same, then they don't need the sorting operation. If the next element and this element are same, they don't need the sorting operation. If this element and this element are same, they don't need an sorting operation. But this element and this element are not same. Okay, so I need to do sorting till here. Okay, and the total cost I pay will be this element say AK. Okay, so what I can do, I can just directly iterate from backward and check how many elements are equal to n, n minus 1, n minus 2, and so on up to 1. Okay, the number of elements which are equal, I can just skip, and whichever a point where the element k is not equal, I can just return the array key itself. Okay, if the array is completely sorted, you can just return 0 for this, for that. Okay, so time complexity for this is just big O of n. You are doing nothing. You are just iterating from backward. Okay. So let's look at the code. If you look at the code, what I have done, I have taken n as input. I have taken array vector v as input here. Then I have made my answer as zero. Why answer is zero? Because it might be possible that array is completely sorted. Okay. Then what I have done? I have iterated backward from n to 1. Okay. If v of I minus 1, which is the current element, is not as equals to I, which means the conflict. Like if I am iterating backward, if there are no conflicts, then it's okay. And if there is conflict, that point is the point where I have to sort, till where I have to sort. Okay. So I will mark that point in the answer and break out of the loop because I don't need to check any further. Now, if answer is zero, which means the array is completely sorted and this loop never break out and answer is still zero, so I can just return zero because my array is completely sorted. Else, I can output my that answer index which I have which I have marked as breakpoint uh, in the array. Okay, so that cost I have to return. Okay, so doing this, I can just directly return the minimum possible cost. Is this clear? This was a very easy problem. Any idea which is not clear or anything which I have not explained, you can just mention in the comments. If you got it, thumbs up, and I will move forward to the next problem. Hmm, Uh, okay, guys, so 3 into 3. Yeah, no problem. You can just now uh, upsolve the next problem. Okay. Okay, guys. So I'm moving forward to the third problem. Okay. What happened? Okay. So in this problem, uh, you need to read it carefully. Okay. Now there are n days, and the sell price of the watch on the ith day is AI. Okay. Initially, you have zero watches. For the first day, from 1 to n, the following event happen. So next, okay. First, you acquire one watch for free on each day. Okay. Next, you may choose to sell up to two watches that you own for AI coin each. Okay. What is the maximum profit that you can obtain by optimally selling items? Correct. So in this problem, what you are asked is that there are n days, and on the ith day, the selling price of any watch is AI. Okay. Now initially you start with zero watches for each day. For each day from 1 to n, one of the following thing happen. Okay. First, you will get a one watch for free. Second, you can choose to sell up to two watches. Up to two watches, which means you can sell zero, one, or two watches. Okay, that you own, which means that you have for AI coins each. What is the maximum profit that you can obtain by selling the items? Okay, so n is 100. You can again brute force it. It will be easy. Correct. I guess brute force will be quite complicated than the optimal answer, right? And AI is up to 10 is to power 7. Correct. So what I have done, let's take one example also for this. So you are given an array A1, A2, A3, A4 up to AN, and these represent selling price of a watch on ith day. Now, uh, what are the things that are happening on each day? You get one watch for free, and second, you can sell up to two watches. Okay, you can sell up to two watches. Now, if we look at the some examples, let's take this one. One, one, two, three. Currently, you started with zero watches. Okay, everyone left. Um, so currently, you have started with zero watches. On the day one, this is let's say okay, let's start with days. So this is day one, day two, and day three. Now, what are the things that happening during each day? Is like on the first day you will get one watch, okay, and the selling price of one this watch is one. Okay, you can choose to sell the watch or not. Okay, sorry, Uh, people are leaving. Like I was looking at the chat and two people left at the same time. Okay, so currently you can acquire this watch and you can move towards the second day where you will get one more watch and the total price of for that selling is two. Then on the third day you will acquire one more watch and the total selling price of that is three. Okay, so how can you maximize your answer? Like what you can do, you can at day one you acquire the watch. At day two, okay, so at day two what you can do, you can just sell that watch, and at day three you will acquire one more watch. Okay, so total watch will be you have two, so you can sell these two watches on the third day, which will give you a total sum of 3 plus 3 plus 2 and which is 8. Okay, so this is mentioned here, like you can just sell nothing on day one, sell one watch on day two, we will get 2 points, and sell the other two watches on day three, you will get 6 points, which is total gives us like maximum answer. Okay, which are 8. Is this clear? If not, I can just explain again. If you guys have any doubt in anything, like you can just please mention in the comments. Uh, Otherwise, I will not get to know that I'm explaining too fast or too complicated. Okay. So this will be a greedy strategy to sell the maximum amount of watches on the third day. Okay. Now, how will I implement it? You need to know one thing. After this day, you can't sell any watches. Okay. So if you are holding watches on the last day and not selling it, it's waste of money. Okay. You should not hold watches here. Okay. Now the thing is, how many can you sell at this point? At this point, how many you can sell? Let's take one more example, like the third one, which was 2735. Okay, this will clear out everything. 2735. This is these are the days: day one, day two, day three, and day four. Currently, you have nothing. Then on the first day, you get watch one. In total, you will get four watches at the end of all the days. Okay, this is clear. Like I will get four watches, and I need to optimize my selling. Okay, what I can do, I can sell one watch on the seventh, uh, you know, second day. So after coming here, I will have like here I have one watch. Here I got two watches. I have sold one. So my cost was, or I can say answer. My answer is currently seven, and it will decrease by one. Now I got to the third day. I will get two watches. Okay, I'm not selling here. I will get here. I will get three watches. Correct. Now, is it better to save these watches and just you know like I can sell up to only two watches. So after deleting two, I will get 10 more to my answer, which is 17. But is that saving one watch worth it? No, it was not worth it clearly. So what I can do is, if I have four watches currently, if I have four watches in total, here I can just sell one watch which I don't want to sell. I will save it for further. Here I can sell both of the watches. I have two watches. I will sell both of them. I will get an answer of 14. Okay. Then here on third day I will get one more watch. Okay. I am not selling it. On the fourth day I will get one more watch. So I will have two watches and I will sell these two watches. So I will get a total answer of 14%, which is 24, which is the maximum possible answer that you can get. As you can see, it was 24. Okay. Now, how will do this thing? Now, let's come to the idea what I will do. First of all, I will definitely gonna sell. I will definitely gonna sell two watches on the last day, or less than two watches. If I don't have if I have no watches till here, I am not going to sell. But if I have at least two watches left, I will sell them definitely. Okay, sell two watches if left. Okay. If you are coming here with one watch, you can sell one. If you are coming here with zero watches, you can sell nothing. But if you have two watches, then you have to sell them. And if you have three watches or more, three or more watches, then definitely you are doing something wrong because you can't store watches somewhere. Like you don't want to store watches till end. You want to maximize your answer, so you need to sell all of them. Okay. So on the last day after this. The days will end. So this is my clear cut point that I will iterate from backward and I will store two of the values here. Like you can say I will make a priority queue so that I can maintain which is the maximum selling day. Okay. So what I will do, I will just store two fives here. Why? Because there are two watches which I can sell if possible. If not possible, then I can just end my selling. Okay. So for after putting all these two values in the priority queue, I will take one out. Okay, and add to my answer. Okay, the top one because I'm making a max priority queue. So top one will be the maximum value. Okay. Then I will go into the this day, day three. Then I will add the cost in the priority queue, three and three. So five has been popped out. You need to take care of that. Okay. Now, when you look at the three, you will again say like these two values are not good. I will sell at the fifth day only. Okay, so I will add one more five. Why it is happening? Because you can assume that you are currently you know the future and you are currently standing here. Okay, and you are holding one watch and you know that in future I will get one more watch and it is optimal to sell because this price is larger than the this price current price. Okay, so you will think that I can sell at most two watches, so one plus one is two, and I have two watches, so I can sell out two watches on the day five, oh sorry, day four, which has the maximum outcome for current scenario. Okay, So consider like this, like I am standing on three and I am holding one watch. Can I sell? It will give me three. But if I store it because I know the future, if I store it, I can sell two watches at 10. So which is better? It is obviously selling 10 better. Okay. So that's why I have put two fives and two threes because it might be possible that while coming up to three, there are some points which are less than three and you need to sell at the point three. Okay. Sorry. Okay. Now I can again sell at 5, cost 5. Now I trade again backward. Now you come to 2. Add 2 7 on the priority queue. Now what is on the top of priority queue? It is 7. So take out 7. Add to your answer. Now go back to the day 1 and add two twos. I am adding it here. Now on what is on the top of priority queue? It's still 7. So take out 7 and add it to your answer. So your total answer is 10 plus 14, which is 24. Okay, so that's how you can get your answer. Okay, is this clear? Is this clear? Like, is there any doubt or is there anything mm, which gone through your head? Anything like that? Anything which is not clear? Why I have done a certain uh, idea or how I implemented a certain idea. So this will be my key implementation, and using this, I will implement my code. Not clear. What is not clear, Ayushi? Yeah, it is better than my recursion. Yeah, recursion. I'm not sure you can use a recursion. IG, please mention in the chat what is not clear so that I can explain it again. Sorry. Mm. Please mention in the chat so the latency is high. So each day we can access AI in any one of the term from 0 till AI. Akshat, I'm not able to understand. No, no, you're not. You can't access like all the terms. You need to keep in mind that there must be enough element in the future where you can sell all the watches. So just think like you know the future and there are some elements A1, A2, A3, A4, A5. And if you are standing at A2 holding two watches, then you must be clear that if I am not selling on A2, please listen to me. If I am not selling on A2, then in the future there is some possibilities where I will sell these two watches with the maximum possible output. Okay, so you need to keep that in mind. So it might be possible on day A3 or A4. It might be possible if it is greater than A2. But you need to keep in mind that you have enough watches. Uh, is this okay? Like you need to keep in mind if there are enough watches or not at every IE. So how can you maintain it? You know that on the day 5 you have to sell all of the items. Okay, and on the day 4 you have a chance to sell on 8 5. So that's why I am putting the values on the top of in the priority in the top of A5. Okay, So that's why I'm iterating backward, because I know I have to sell at most 2 points here, and here I can hold any number of items. Okay, x, y, x1, x2, x3. But here I have to have only two items. Okay, so that's why I was iterating backward. If this is clear, then I can show you the code. So as you can see, I have taken n as input and the array as input. Then I have made the max priority queue. Okay, this is the max priority queue, and I have made my answer as 0. Now you can see I have iterated backward. The person can work. N is 100. Yeah, it can work. Like, okay. Yes, you can brute force it. Huh? I was just said. It's okay. But this is optimized. Like, it was the key idea that struck my mind first, so I have done that. I have not thought of recursion in the like any scenario. So what I've done, I have iterated backward, and for each a day, I have pushed two items in the priority queue, because there is possibility of selling at most two items on that day. Okay. Now, if priority queue is not empty, you can just add the top element to your answer and pop it out. Alright, just you have to do just this. Okay, and after that you can just output your answer. Anything which is not clear in this complete part of adding two was because on each day you can sell at most two items, and I don't care if it is coming on the top or not. If uh, if it is the maximum element, then I will try to sell two watches on this day. That's clear. Okay, that's my approach. Alright. If this is clear, I can move towards the next problem. Okay, which was D. D was quite interesting problem. Like, we can put a thumbs up and we can move towards the next problem. Okay. So total how many days we can sell? We can sell on how many days, it doesn't matter. Like uh, we are selling. Wait, look. There are say there is an array 1, 3, 4, 5, 7 or 1, 2. Okay. So these are the array. Uh, we can sell the watches on any of the day. Okay, on any of the day. Like I can skip these days also, and I can choose to sell two watches on these days also. Okay, to cover up these. But I have to keep in the mind that after the last day, there must be no watch left. Okay, so if you are selling two watches on these days, two watches on the last day, you have to sell n minus two watches on this subarray of days. Okay, and same goes on here. Like if you are not selling here, then you have to sell n minus two uh, n minus two watches on this subarray of days. So you need to take care of, like, after coming to the last element, there must be no watch left. Okay, all the watches must be sold out. Now, if I look at this value like 7, I know the future. If I'm standing here, I can say that I am not going to sell this watch on my day 1. I will try to sell this watch on day 3, day 4, day 5, or day 7, because it will give me a better output than selling on day 1. So I will hold it. Then I will go on the day three. I will get two watches. Okay. Now I need to take care that if I am holding one more watch, there must be enough space to sell. Okay. These three can sell up to six watches. Okay. And these are the maximum element if I'm currently looking at it. So these are the maximum element and it can sell up to six watches. I'm currently holding two and I will get one from here. So total of five watches I will get. So yeah, I can I can hold them and sell it on these consecutive days. In this manner, I can sell two on seven, two on five, and one on four. So it will give me a total of whatever. Okay. So I can sell all my watches till here. Then I will go here. I will again see like I am holding a current watch, and it is better to sell this watch on current day, which will give me one as my output. But if I hold and sell two watches on two, it will give me four as my output. So which is better? This is better. I will hold two watches, and after that I am holding nothing. So I will come out with zero watches left. So this is the optimal way to sell all the watches. Okay. So if you are looking at this particular thing, you are selling at most two watches. Correct. So for each of the day, you can maintain a priority queue and set that I will send I will sell two watches here. Okay. Then I will sell two watches here. Now priority queue automatically sorts the item in such a way that you don't need to check how many watches you will sell on each day. It will always give you like, oh, you are holding two watches and the maximum I have is seven. You should sell this watch on seven. Okay, so that's how you can just uh, sort out all the elements. Is this clear now? If this is clear, then we can move forward. Shatopi. Okay, so let's move towards the D problem. Okay, ascents and descents. Okay, in this problem, what you are given with for a permutation P of integers from 1 to n, let Q be the unique inverse permutation of P. Inverse permutation of P is that like for each in P of I, it will give me I. Okay, so it's say Q of Pi will give me I. Okay, we define a function P as summation of I is equal to 1 to n minus 1. Pi is less than Pi plus 1 plus summation of I is equal to 1 to n minus 1 and Qi is greater than Qi plus 1 where mod x is 1 if x is true otherwise. Okay. In other words, Fp is the sum of the numbers of ascents in P and descents in Q. Given n and k, your task is to find a permutation P of integers 1 to n. What tips will we give to solve the problems that are on the tougher side like D and E on this contest? For D, you need to like have a great observation. Like it was an ad hoc type problem, to be honest, for me. I was not able to come up with any kind of like a particular algorithm. Like I can use a DP here or I can use something like that here. It was an ad hoc problem. It just directly stuck in my mind. No, I can just break out like this, and it will obviously give me the optimal output. So this was an ad hoc type problem. So you need to for ad hoc problem you need to solve a lot of problem so that you can get an idea if some problem repeats itself. Like I have seen something like this in code forces also. Some it was diff2f something like that problem, or div1 plus div2f. I'm not sure in which he said the same thing like n is 4. I have gave output for n. Now you have to find for n is equals to 2e5. It was something like that. I've seen some problem like that in CodeChef also. Code forces. Okay. So back to the problem. You are given n and k. Your task is to find the permutation p of integers 1 to n such that fp is greater than equals to k. Okay. So which means this formula is should be greater than equals to k. Sorry. Okay. So let's start with this problem. We will start from the basics. Okay. Basics of the problem. First, what we are given is p is a permutation of 1 to n. Okay. And there are two things which are given like ascents and descents. Okay. From the name, you can just understand ascents means going up and descents mean going down. Okay. So it's clear from directly from the name. Now, what an ascent will be if I write it, if I write an array a1, a2, a3, an ascent will look like a1 is less than a2, and descent will look like a1 is greater than a2. Okay, so these are ascent and descents, correct? Now, coming towards the formula part. Okay, now you need to keep your focus here because I am going to explain some of the things which might be new and which might be typical a little bit, but I will try to keep it simple as possible. So currently, what your FP is defined as summation of Pi is less than Pi plus 1, okay, plus summation of Qi greater than Qi plus 1. Now, okay, so I forgot to explain what is a inverse permutation. So let's write inverse permutation. Inverse permutation is something like uh, your if your permutation is P1, P2, P3, P4. Okay. So your inverse permutation will look like P of P1 is equals to 1. So P of P1 equals to 1. Okay. So which means like what I can say, uh, somewhat like if you have a permutation 1, 2, 3, 4, its inverse is just 4, 3, 2, 1. Okay. You can just say for P of P4 is 4, something like that. No, create a P permutation of descents. So it's like P of 1, which means this P of P1 must be equals to 1. Okay. So, and P of P2, which is 2. Okay. So it must be equals to 2. Like you need to satisfy these conditions. Okay. So there might, this is a inverse permutation of itself, but there are multiple permutation that can exist at this point. Okay. So that's what they are telling that inverse permutation QPI is equals to I. Okay. So you can just say Q of uh, Pi is like I can take P3. So Q of 3 should be equal to 3 like that. Okay. So you need to create a permutation Q1, Q2, Q3, Q4. For this it is same. Now, there must be, this was the inverse permutation part. So, now coming back to the formula, which was, wait, so this was my formula. Yes or no? Okay. So, in this formula, I need to maximize this part and maximize this part also. Why? Because at the end, I need to return a permutation P. I need to return a permutation P such that it's a formula of P, FP, it must be greater than equal to K. Now, why should I go for a closest value when I can just do a maximization of this part and then maximization of this part? So if I maximize both of them, the answer will always be greater than equal to K. Correct? It's like no maximum plus maximum is always maximum. So it will always be greater than K. Mm, It might be like the answer don't match with the example, but it will always be the maximum result. Okay. So this is clear. I need to maximize this part also, or I need to maximize this part also. Okay. So let's say this is my first term T1 and this is my T2 term 2. Okay. Now for each term T1, this is Pi is less than Pi plus 1. Okay. Now, what this defines is like you can take a permutation in any order 6, 10, 7, 8, 7, 9, 8. Okay. All right. So, in this particular permutation, you have to iterate over all the consecutive element, say 5 and 1. Is 5 less than 1? No. Okay, so this gives us 0. 1 into 1 is less than 2. Okay, 1. 2 is less than 3. 1. 3 is less than 4. 1. 4 is less than 6. 1. 6 is less than 10. 1. 10 is not less than 7. 0. 7 is less than 9. 1. And 9 is not less than 8. Okay. So the total outcome is 1 plus 1 plus 1 plus 1, 6 times. Okay. So this will give me uh, ascend of 6. So can I call this ascend? Okay. Ascend means the previous part is smaller than the next part. Okay. So ascend is 6 for this permutation, and descend is just opposite, which means 5 and where it was 0, 5 and 1, which was 0 there, 0 there, 0 there. So ascend is 6 and descend is 3. Okay. So for this, I can just say something like that. Okay. Now I need to maximize this. I need to make a permutation such that these both values get maximum. For Pi is greater than Pi plus 1, the maximum thing that can exist is 1, 2, 3, 4, 5, something like that. A sorted array will always give maximum ascent. Okay, correct. Any doubt till here? And a sorted array decreasing sorted array. Okay, will give us maximum descent. Okay, which was the that q part. Okay, qi is greater than qi plus 1. Correct. So don't get confused with qi currently because I am not working on qi right now. What I'm currently doing is I'm just trying to make this true. Alright, that I'm trying to maximize it. Now, can I in this particular thing like qi and qi plus one? What this particular thing means it's just right q of pi is greater than q of pi plus 1, something like that. Okay, so these are I, it will give me I and this will give me I plus 1. It was written in the question, yeah, that q of pi is I. Okay. So q of pi is I and q of pi plus 1 is I plus 1. So in words what I can say that it means the position of I is after the position of I plus 1. It's saying the same thing because I is greater than I plus 1, correct? I is greater than I plus 1, so position I must be after position I plus 1. Yes or no? Yes or no? Is this clear? If this is clear, then the whole problem will be very easy. Just tell me if this is clear till here. From here on, the problem will be very easy. So that's why I'm just trying to ask. Anyone? Okay. So I'm moving forward. So I am cleared that for the Q part, for this part, I need to take care only of this thing. Okay. Now, how will I maximize my answer with this? So for this, the perfect scenario will be like 4, 5, 4, 3, 2, 1 reverse order because all of them are descents. So it will give me the maximum descent. Okay. Now, there's one only one conflict left, which is for the P part. For summation of pi is less than pi plus 1. This was my array which I formed, and for qi is greater than qi plus 1, this was the array which I formed. Both of them are different. Now, now I'm stuck here. Okay, this is sorted, and this is sorted in reverse order, like you can say, a descending. Or this is descending array. This is sorted ascending array. Now, uh, so how can I just make a permutation p such a way that it's always give me like uh, a good answer or the maximum answer. Let's take for the example 6. Okay, okay. So our this, okay. So what I can do for n is equals to 6, I can make 1, 2, 3, 4, 5, 6 as my assigned array. Okay, if this is my assigned array, I will get the maximum result out of it. Correct. Now let's break it into blocks, which is 1, 2, 3, and 4, 5, 6. Correct. If I break them into blocks, now this maximizes ascend. And now if I replace the positions of these boxes, so it will look like 4, 5, 6, 1, 2, 3. Now this maximizes my descent. How? Let's check. Okay, let's check one by one. In this is my permutation array. Now I am checking. This give me ascent of 1. This give me ascent of 1. Wait, this give me ascent of 1. And this give me ascent of 1. Total ascent is 4. Correct. Now let's check for descents. We will check one by one. Okay. What my problem was, I must be greater than I plus 1. Okay. So it was like this, right? Now this means that uh, I plus 1 will be on the left side of I. Okay. Please keep up with me. Okay. In this, you have to focus more properly to understand. Okay. So now this means that I plus 1 must be on the left hand side of the I. So I can just check in this array, right? Uh, is 2 on left of I, for the left of 1? I'm checking for 1, 2. So is 2 left of 1? I can say no. Is 3 left of 2? No. Is 4 left of 3? Yes. Is 5 left of 4? No. Is 6 left of 5? No. Okay. So it gave me one descent. Okay. So the total answer is 5. So total answer was 5. Okay. For this, but. Okay. If we look properly, like uh, we are ordering the blocks in this format, right? The maximum block, let's say k here, then this block k minus 1, and so on. Okay. We are placing blocks like this, correct? So I can just say that this will give me an optimal output because the blocks k have the maximum elements, right? And the block k minus 1 will have the elements which are less than these. Okay. So now I have to break these blocks. They break them, and each descent will come in this format. Okay. So at this point, I will get a descent. Okay, so if you want to visualize, at these point I will get a descent. As you can even see, 4, 5, 6, 1, 2, 3. So 3 was greater than which is 4 was on the left hand side, and I have break the block here. So only one descent was here. So I can say that there are only one descents on each of the block pair, correct? And for each of the ascent, I can iterate over all the k boxes. Okay, so they will give me ascents. Now, this is a complete simple loop of a simple mathematical thing that if you have and x and y, now you want to maximize them x plus y, so you can just say your x into y must be equal to n, which means you can just make x and y as your root n. Okay. So it always maximizes the result if you want to maximize this. So I can just say that I will break n into k n into root n blocks with root n elements in each of them. Okay. So this will give me root n minus 1 into root n minus 1 as my answer. Because for each block there are k minus 1. Like if a blocker has size k, then k minus 1 ascents are there. And if there are k boxes, so k minus 1 total descents are there. Correct. So they can just multiply. Is this clear? Is this clear? Is this clear? Anyone? Any problem in this? Anything which is not clear? If not, I can just move towards the code. And for the coding part, what I have done, as you can see, I have made an array for boxes, and for each boxes, I will store some element in it. Then you can just iterate over 1 to n to form a permutation. I have taken s as square root of n. Alright, to keep in mind there are root n boxes and root n element of each box. Now, what I have done, I have assigned each element into their particular box by taking the remainder. Now, if remainder is 0, you can take remainder as value of under root n. Now, for each box b of each box b of n, you can just push that particular index. Okay. Now, what you are seeing is that after putting each values in that boxes, what I have done, I just iterate from last box to the first box because I've arranged my boxes in the reverse order. Then you can just output each element of that box. Okay. You need to keep one more thing in mind that you're not asking questions, anything like that. I think this is not clear. I can re-explain the whole problem. Just drop a comment. If you guys want, I can just re-explain the whole problem. Just drop a comment. If this is if this gave you any problem. Because it's quite tough to understand directly. Look, I will run on example 6.6. Okay. Now what I'm doing, there is this permutation. So it will be divided into root 6 parts. So root 6 means it will divide into two parts. Correct. So the boxes of 2 will be made. Correct. Give me a short overview of this one. How to explain how root n boxes gives maximum sum ascending sense. Okay. The short overview and how to okay and maths problem. Look. for the 6 n equals to 6 and k equals to 6, I need to make at least pairs so that it increases k or equals to k. How can I do that? Now, if you look at particular index, I have you know two boxes, so I can just take modulus of both of them. So if I take modulus of one, it will give me one. So so there are root n boxes. Sorry, so there are root n boxes. So there are two boxes, and when I take modulus with one, so it will give me one. So I can put it in the first box. Modulus with two, it will give me one. So I have to put it in the first box. For two, I can put it in the second box. Three, I can put it in the first box. Four, second. Five in the third, and six in the second box. So I am distributing all the n elements into under root n boxes such that each box has root n elements. There are root n boxes and each box has root n elements. Now in the by of distributing like this, that one element here, one element here, one element here, and so on. Because now what I am going to do, I am going to reverse all the boxes, which means this will come here and this box will go over here. The boxes will be look like this. Now my assigns are still same, which are 2 is less than 4 and 4 is less than 6. Give me two assigns here. 3, 1 is less than 3, 3 is less than 5. Give me two assigns here. But descends, if you look at this, 2 is on the left of 1 because I must be greater than I plus 1. So the position of I, 1, is greater than position of 2. So that's why I have placed 2 in the first box. So this will give me a descent. Now 2 is on the left, 3 is on the left of 2, which is I have to check for 2 1. Now 3 2 is false, this is true. But 4 3 is true again. Okay, 4 3 is 2, true. Then check for 4 5 4, it will give you false. But 6 5 it is true because 6 is on the left of 5. So that's how you can make three more descents. Now the total summation is 7, 2, 2, 4, 4 plus 3, 7. There are 4 ascents and 3 descents. So it is greater than k equals to 6. Your k equals to 6. So this is the most optimal approach which you can do. Now coming to the part that why under root n gives you maximum result is like you might have heard of uh, that theorem we have studied in class 10th or class 8th. Like you want to calculate, you want to find the maximum area or maximum parameter of rectangle having certain area, correct? Having area x. So you were tasked to find like the maximum parameter of the rectangle having certain area. So you want to maximize x plus y at that point, 2x plus y. So it was always right, no, the x into y must be equals to that area. So you take, so it was like something like that problem. I am not remembering that problem particularly. So it was like if you want to maximize, uh, if you want to maximize summation part, and you have given with n variables. So the best way is to take two root n's, divide both of them into two root n's, and this will always give you the maximum summation possible. Correct. Operating on this and operating on this will give you the maximum summation possible. So it was some question I'm not rem- reminding right now. I'm not able to remember that it says something like that. Same that if you want to find the maximum area of the rectangle with a certain parameter of certain area, I'm not sure. So it is always a square. Correct. The maximum parameter of a rectangle with certain area is also square. It's something like that. So from there you can just say that It's always true that if you want to maximize x plus y and you have given with a value n and you need to divide n into x and y, you need to divide into x and y. So you have to choose root n as x and root n as y, and it will always give you the maximum result. For example, you can take anything uh, like mm, n is equals to say 16. Okay. Now n is equals to 16. You can just uh, divide both of them into any part. Like if you want to uh, divide it into some values, uh, say it's always like 16 can, how can a 16 happen? There's a value 8 to, like, like that. You can just, I'm not able to get it. Like, it will, what was the question? Like, maximum area of the rectangle is, I'm not able to remember that, but it's for something like that. When you take the maximum area, it's always like you have to divide them into root and parts. Okay. So 8 into 2 will give you 16. So you can divide into 8 part and 2 part. And when you do 8 minus 1 and 2 minus 1, like 8 minus 1 and 2 minus 1, so it will give you 7. But if you divide into 4 part, so 3 minus 1 into 3 minus 1, sorry, 4 minus 1 into 4 minus 1 will give you 9 as the result, which has the maximum output. So it was like that. So dividing into root and parts will always give you the better answer. For the short overview, you can just assume that in this problem, what I have done, if there is a certain array, I have divided that array into root and parts. Now uh, I'm certain that if the array is sorted, my ascents will always be root n minus one. Okay. Now I need to increase my descents also into root n up to root n. Okay. So my ascents will always be root n minus one, and then for each boxes. Okay. For each boxes, say there are three boxes, and it will give me root n minus 1 ascent, root n minus 1 ascent, root n minus 1 ascent. Okay. Now I need to maximize the descents also. So what I will try to do, I will try to place one here, then two here, because two should be on the left hand side of one, then three should be on the left hand side of two. Okay. So this will give me a descents, all these descents from one to three. Now, I cannot place 4 here because I have no box here. So I will try to place 4 again here. Okay. Then I will try to place 5 here, 6 here. As you can see, these ascents are still true valid and descents are also being formed like 4, 5 and 5, 6. Now you can go with 7. You can place 7 here, 8 here and 9 here. Now this will be your array of permutation for n equals to 9, which gives you the maximum ascents and descents. Okay. Is this clear? So that's why it was giving the maximum result. Is this clear? Very complicated. Uh, okay. If it is very complicated, you can just think it like this. If I need to make ascents and descent maximize, you need to know that root n dividing into root n parts will always give me the maximum result because root n minus 1 into root n minus 1 is always larger than any x or y split. Okay, x into y split. If you know this, then you can divide into root n boxes and fill manually. If you fill manually, then you can get to know what is happening. Like when I fill manually, I, I have just what I've done. I have placed one here, then two in this box, and three in this box. Uh, okay, so doing like this, you can just maintain all the elements and check that these all elements have modulus with root n as 0. These all element with modulus with root n has 1. These element with modulus with root n has 2. So you can just directly take root n values and modulus with root n values and just place in these boxes. Okay. So that's what I have done in the code also. I have taken modulus with root n, and for each root n I have placed them into that particular box. For each modulus I've taken that element and put it in that box. So I traded on the all the boxes backward in the backward order and print all the elements. So that's what I have done. Okay, is this clear? Now we can move towards the last problem of today's contest. Last problem is quite hard. It has DP and probability stuff, so it will be a total mathematics devastation disaster. Okay. Now, coming to the last problem of today's contest, this problem states that for a sequence A1, A is equal to A1 to AN, we define a FA function in the following ways. Let Pi is equal to the GCD of all the elements up to I. Okay, prefix of I, it's stating prefix of I is the GCD of all the elements from 1 to AI. Now, FA is equal to number of indices I from 2 to N, such that prefix of I is not is equal to prefix of I minus 1 at that point. Okay, this is my first prerequisite of the array. Okay. Now the problem starts from here. Given an integer m, define a gn as the expected value of fa. Expected value, which means it's talking about probabilities of fa, where when a is uniformly randomly selected among all m raised to power n arrays, which means all possible arrays which you can select, satisfying the following condition: mod length of a is m and all elements for ai is less than equals to m. You need to find a limit is equals to n tends to infinity gn and with modulus up to 998 Okay, formally it can be proven that the limit both exist is a rational number in the form of p. You just probability stuff. If you need to just return p into q inverse. Okay. Now, how to do a Q inverse? You can just do using mod minus 2. Take power of mod minus 2, you will automatically do a Q inverse. Okay. So this question is quite tough to understand because it asks you limit thing. Now, the let's explain what the problem statement particularly states. Okay. You can just say, let's imagine you have a current. Uh, let's imagine you have current GCD value as mm, so what like V. Okay, you can take any of them. Now you pick any random integer from 1 to n, because 1 to n, because my array consisting of these elements ai is from 1 to n. So take any random integer x. Okay, this is my random integer, right? Now my new GCD after that, my current GCD is this. I have taken a random integer. So my new GCD will be GCD of v comma x. Okay. Now this new GCD uh, must uh, must divide v. Why? Now if my GCD must divide v, I can state that uh, my new GCD will be same as v or get decreased, but it can never increase, right? Is this true? Right. So I can just say if my new GCD must divide b, I can say GCD will be equals to v or it will get decreased, but it will never increase. Now, talking about that limit n to infinity, this states that my sequence is infinite and the GCD will eventually reach 1. Okay. You will eventually get some prime number and it will reach 1. Okay. Your GCD. You will eventually reach some point of time where the GCD will be 1. Now, sorry, but here we can say, here we can say that I am particularly interested uh, how many times, like how many times uh, it gets strictly decreases, like how many times it gets strictly decreases before reaching this one state. Okay, for this one state. Okay, I'm interested in this part. Okay, so that's my whole problem. If I sum up it, okay. Now let's take some example. Like if my GCD was 12, it can go up to, it can go like 6, 4, 3, 2, and 1, or it can stay 12, but it can never increase to 24 or something. Okay, is this clear? 24 or something else. Because GCD can never increase, it will always decrease. You can take any example. You can take this area as example. So it's currently in start, my GCD is 6. Then when I take it GCD with 4, I will get a GCD of 2. Then I will take GCD of with 3, I will get 1. GCD with 2 will give me 1. 1 will give me always 1. Okay. So as you can see, it will get decreased. It will never increase. Okay? So this was a part which you need to take care. Now I am was talked about the expected value of that particular element, right? Which I have taken. which was G. Expected value of G was I have taken V. So G, you can say V, is the number of uh, decreasing decreases that will happen, okay, to reach one. So my expected value of any GCD is the number of decreases that will happen to reach one. Okay. From the current GCD which was V, I can say from V to 1, the number of steps is my current expected value. Correct. Now, if you look at the recurrence of that particular formula, which is A of my GCD, I can pick any number from 1 to m, correct? And there are n choices, uh, and there are n choices, and the cost of like if GCD stays same, there are two options, like if I have done a GCD with X, it will stay same, or I have done a GCD with some X value and it decreases. So I can just define that this is my cost 0 and this is my cost 1. So from for expected value of V, which means reaching at state 1, can be written as summation of my any X value from I to capital M. I can say cost, which can be 0 or 1, plus expected value of GCD of V and this X value. Okay, V and this X value. Divide by, there are M options which I can pick from. So that's why divided by M. So this will be my formula. Let me write it clearly. So expected value of V will be summation of cost plus expected value of GCD of V comma X. This means just for this V, I will take the next element and take the GCD, and it will give me the divided by M options. Okay. So this is the formula for the expected value of I X. Okay. Now you can just manipulate it to find uh, derive more clearly, such that you can just multiply it here. So it will look like M into EV is equals to and for this, what I can do, uh, what I can do, like summation of 1 plus E of GCD plus cost okay, cost till V into E of V. Okay, what I've done, I have just multiplied my EV okay, on this hand side also. Okay, so this GCD when multiplied by expected value of EV, then it will convert into GCD normal, and the cost will be multiplied into EV and divide by M. So while moving M here, it will become M of EP is equals to summation of uh, 1 plus EGCD plus cost of V into EV. Okay, now you can just take these both terms and subtract it. So it will be like M minus CV cost of V into EV is equals to summation of this one plus summation of E of GCD. Okay, you can write it like this. Correct. Now this one is just simply accounts. Then non-multiples, like where the GCD decreases, right? So I can rewrite this equation, like EV is equals to 1 plus uh, the summation of E of GCD divided by M minus cost of V. Okay. So this will be my further equation. Okay, okay till here. Most of the guys have left till now. Okay. Now, what I am going to do now, I will group using GCD. This is something like this is hard topic. Okay. Now, iterating on X is slow because I cannot iterate my summation on X, right? Iterating is not possible. So, what I can do is instead of sum over X, sum over uh, divisor of our GCD, GCD of B. Okay. So, instead doing this, I can just count. I can make a function count where I will out push these two values, and it will give me the count of X which are less than is equals to M, such that GCD of V comma X is equals to G. Okay. So this is my function count, which takes two values B and the new GCD, and it will tell me that uh, the number of X, number of values X which are less than equals to M, such that GCD of the B and X, which means the current GCD and X will equals to the next GCD. Okay. So this is my function. Now I can uh, rewrite my formula in such a way, like I can rewrite that count of V comma G will be just summation of K is equals to 1 to M upon G, because it will go up to till here only, and GCD of V upon G comma K, it should be 1. Okay, this should be equals to 1. So my count of Vg, which was count of X less than equals to M, such that GCD of V comma X equals to G should be looking like this. Okay, it is known as Mobius function. I'm not sure. Okay, this is Mobius function. Now you can just maintain two or three variables here, so you can just optimize it or more using a sigma, so that you can just look at more easily, like okay. So now you have to find the uh, thing is, now you need to find that how to take the sum of all the values, right? Because you are asked to take the sum of the all the values of all possible arrays which you can make, correct? So I can write that as sum is equals to summation of expected value of G multiplied by this count function. Okay, this count function of yours, count of V comma G. So this will give me the maximum possible output. Now you can just uh, do some more operations on there, this to make uh, say you can take a value T as G into divisors. So you can just write it as summation of basically summation of uh, t divided by v m on t, then just summation of g divided by t eg into you can take any variable here. If I've taken some value x and t upon v. So you can just make this formulate it uh, more properly, which I'm not going in depth because it's quite tough and it might be going over your head. So you can just understand it that currently my sum of all the values is expected value of current GCD into the count function of V and G. Okay. So this was my last formula. So okay. Doesn't matter. We are going towards this particular thing. Now, so if this is my value, I can just make my algorithm flow like this. I will calculate all expected value of V uh, pre-computed. Okay, I will pre-compute all the expected value of V in terms of cost and array. Again, one more array. Okay. Now, once our expected value is known to me, what I can do, I can just uh, save its what you can say, save what expected value is giving to me. Like you can say, its output for future. Okay, so I will save it for future multipliers. Okay, because in future EV will be deriving the other values. Like if EV is first value, then it will go towards X, then Y, then Z, and A and B, and so on. So this will be focusing on all these values which are coming in future. Okay, so I need to save this. Okay, now for each for each a for each value that is coming, but I can maintain an array A, and in which each value of B is coming. I can just multiplies it for the future updates by k into V, and then I can just update it with our expected value of V. Okay, multiplied by our cost function. So you can just cost of sorry count function with that what was the formula and g comma v. Okay, so count of function, this will give me cost, so I can just update my array A accordingly, and then I can update my contributions to like how much this particular expected value will contribute into the future. Okay, now now I can just come up with the implementation part. uh, I can see the chats. This chat's deleted, or I can just not see the chats. Mm, I'm not able to see any chats. This problem from my side. No, chats are not visible. Let me quickly just message. Mhm. I'm not able to see the chats, but okay. So let's move towards the implementation part. How I implemented it. This is my function because I have derived the formula. I've broken the cost function into like first count function was uh, written in this form. So you can just maintain this also in some function so that your array will look more sorted. So I have pre-computed the all the expected values. I've stored the mu also. I've stored the p values also. Okay. How let's go from here. Okay. So first I've called my pre function, and here what I've done, I've taken m as input, and I made three things: dp, a, and c. A and c are the array and the cost contribution, which was in the future contribution for e. Then I've taken the total, and I've iterated from 1 to m. If I is 1, then dpi is 0. Okay. Else, my value is m divided by v, the total number of, the total number of iteration that it will done. Okay. So, the total number of iteration, or no, you can say total number of mm, the division element, like m was the total number of elements, and I, which is I am trying to place in that particular array, so it will give me that number of gct what is left. Then my term one is m divided by I, m minus m divided by I. The second one, the second term was cost of I. Okay. Then what I've done, I have multiplied that n divided by I with my array A. Then my the total what I've done, taken the sum of all the three terms and updated my DPI with the inverse of T1. The formula will become like T1 plus T2 plus T3 divided by T1. Okay, which is just m minus m divided by I multiply by Ci multiply by AI into m divided by I. Okay, divided by uh, m minus m divided by I. Okay, so that's what the DP. I have stored in the DP, and you can take total as total plus equals to DPI. After that, if DPI is not equals to 0, which means DP is filled at this point, you can just iterate from I is equals to 1 to m, and for each skip of I, you can formulate your muje here, and if your muje is 0, you can just continue out. If else, you can just take out the value of DPI, then check if your measure was minus one, which means it was not never computed. So you can just update your value as your inverse value, which is mod minus value. You just made your value as negative value. Okay. Now you can just update your AJ value, AJ array with array as your array at j point as array j plus that particular negative value if you have done negation, or as your dp is just particularly dp you have added into aj, you will aj will be updated now. Now you have to update your contribution also. So for updating a contribution, what you have done, yeah, I have taken the number of additions that will be possible after taking the particular element, which will be array I into m divided by I modulus mod. If it is not equal to 0, you can just iterate over all the possibilities of j from 2I to m at I skips. Same thing you have to do here also. You have to take cj, your contribution j, and update your contribution with that particular ai into m divided by I. Okay. Now at the end, your total will be modulus inverse of total into modulus inverse of m, which means total divided by m. Okay, which I have done in the starting, 1 divided by m summation of that your cost function and all. So this is just modulus inverse function. This is power function. Now this is my pre-compute function in which I am computing my mu. Uh, Mu was nothing, just taking that multiples, how many future. if I, what uh, you can say something like in future, it will contribute to how many things like your your count function was g comma value is equals to summation of that k is equals to 1 to m divided by gcd of v divided by g comma k should be equals to 1. You can rewrite that into summation of mm, some function mu d, okay, mu I into that m divided by g into d. So that's mu it is. So you can just write it at mu I. Now you can iterate from 2 to n. If p is true, then you can just say that you have pushed your value into that pr function, pr vector, okay, and you have updated your mu I as minus 1. Then you have iterated from p on all the values of pr. Then check if I into p between the values and the pr is greater than equals to n. Then you can just break out because you don't need them and update your is p at I into p is false because your p is not true. If your p I modulus p is 0, then you can update your mu I into p as 0 and break out as your mu I into p is equal to previous minus mu I. Okay, so that's how I have filled my mu I array. Okay. So that's it for this problem, and I'm done from my side. Uh, and this was the push contest discussion of the 5 problems for today's contest. I don't even know what it is. Okay, so mm, I'm clear for my side, and I know this question is really hard. Like it was a 2000 or plus rated DPM probabilities problem, and it's if you're not able to come up with the solution, it's okay. It's totally fine, and you don't need to because nobody asks these kind of problems in real life interviews as such. Okay, so that's all for today, and I hope you were able to understand all the problems which I explained. Um, if not, you can just ask me in the comments also. And thank you for joining. Have a nice day ahead. Bye bye.